Hi, in this video I am going to show you how to solve Bernoulli differential equations. Bernoulli differential equations are usually written in this form. dy over dx plus pxy is equal to qx y to power n, where n is anything other than 0 and 1. So this is what a Bernoulli equation looks like. In order for us to solve an equation like this, we got to get rid of this portion and transfer this equation into a first degree linear differential equation, then find the integrating factor, multiply by both sides of the equation, and solve that problem. So the first step in equations like this, step number one is multiply both sides of equation, by y to power minus n. So if we do that, we are going to have y to power minus n multiplied by dy over dx plus px multiplied by y to power minus n multiplied by y will be y to power 1 minus n equal to qx, and y to power minus n multiplied by y to power n is 1. So now, in this form, we have transferred this to a linear first degree differential equation. Then our second step, step number 2, is to assume v equal to y to power 1 minus n, and transfer this equation in the form of dv over dx, then solve that equation by finding the integrating factor, then come back to this assumption and solve for y. So let's look at one example. Let's say we want to solve this example. dy over dx minus y over x is equal to minus y squared over x. Let's say we have an equation like that. So if we compare that equation with this form, the value of our n in this case, our n is equal to 2. So the first step is to multiply both sides of equation by y to power n. So we have to multiply both sides of equation by y to power minus n, which is y to power minus 2. So if we do that, we are going to have y to power minus 2 multiplied by dy over dx minus y to power minus 2 multiplied by y to power 1 will be y to power minus 1 over x equal to minus y to power minus 2 multiplied by y to power 2 is equal to 1 minus 1 over x. So this is our first step. Now, step number 2, assume that v is equal to y to power 1 minus n. So assume that v is equal to y to power 1 minus n, which in our case, our n is 2, so v is equal to 1 to power 1 minus 2, so is equal to y to power minus 1. So if our v is equal to y to power minus 1, our dv over dx will be equal to minus 1 multiplied by y to power minus 1 minus 1 dy over dx. So if in here we solve for dy over dx, we are going to have dy over dx will be equal to minus y squared dv over dx. Okay, minus 2 and minus 2 is minus 1 and minus 1 is minus 2. So dv or dx must be multiplied by y to power 2. So now that we have the value for dy over dx, let's go ahead and plug that value in this equation. So we are going to have y to power minus 2 multiplied by dy over dx, which is minus y squared times dv over dx minus y to power minus 1, which is our v, minus v divided by x is equal to minus 1 over x. So this y to power minus 2 multiplied by y to power 2 will be minus 1 minus dv over dx minus v over x equal to minus 1 over x. So let's multiply both sides of the equation with minus 1, so we are going to have plus plus plus. So with this trick, with this technique, we transfer our Bernoulli equation into a first order linear differential equation. Now, we can solve this by finding our integrating factor, which are integrating factor mu x is equal to e to power 1 over x dx, which is equal to e to power natural log of x. So our mu x is equal to x. Our integrating factor is equal to x. So let's go ahead and multiply the integrating factor, which is x, in this equation now. We are going to have x dv over dx plus x and x will cancel out, plus v is equal to 1. X multiplied by 1 over x, x and x cancel out, we are going to have 1. Now we can rewrite this equation as dxv with respect to x is equal to 1. Now, in order for us to solve this, we have to take integration of both sides. So if we do that, on left side we are going to have xv, and on right side we are going to have x plus c. So from here, we can solve for v. We got to divide both sides by x. On left side, we will have v will be equal to x divided by x will be 1 plus c divided by x, c over x. So this is our value for v. Now, we assume that v is equal to y to power 1 minus n, or y to power minus 1. So v is equal to y to power minus 1. So this is equal to 1 plus c over x. So if y to power minus 1 is that, so y will be equal to 1 divided by 1 plus c over x. So in Bernoulli type differential equations, we have to find out what our value of n is, and these were the steps to solve a problem like that. I hope you liked it. If there is any problem that you want me to solve, let me know.